A few housekeeping items before we get started. This webinar is in broadcast mode and everyone on the webinar is muted, except the speakers, of course. If you have questions, please put them in the GoToWebinar question panel, which you should see on the right-hand side of your screen. We'll have about 40 minutes worth of content today, and then we'll open it up for Q&A. And finally, this broadcast is being recorded and replay information will be sent to all registrants one day following the broadcast. And with that, I'm going to turn it over to Jim.
Thank you, Anne. And I want to also thank my partner in this webinar, Jon, for joining us today. I really appreciate his participation in this webinar. And so to kick this off, let's just refresh what Semaphore is. Semaphore is a semantic AI platform. It's a platform that extracts data from text. And that allows you to use your information assets much more effectively by providing semantic harmonization across repositories. You can extract explicit entities and facts from text, and that allows you to provide that level of harmonization across your business that is so needed. And it does this through a model-based approach combined with a best-in-class NLP engine. And it's the combination of those two capabilities that we're focusing on today. When we say about Semaphore being a Semaphore AI tool, when we look at the overall spectrum of what artificial intelligence covers, and included in that are these sections up to top. And this is where Smartlogic is focused with our machine-trained NLP engine combined with our rich semantics that we add to our modeling capabilities. And when we combine those two, that's how we deliver the capabilities that we have. So the background for this webinar is AbbVie, one of our clients, who's doing really exciting things with Semaphore. They had just completed an upgrade, and they noticed something working a little differently between the old version and the new version, specifically around dealing with their biomedical vocabularies and how they were being used downstream in their text analytics projects. And so Jon contacted me and brought this up, and I said, I think this is something we need to look into, but why don't we look into it as an opportunity to present what we learned at KM World, which was the following November. This was last year, and he said, sure, let's do that. So we worked on that, and we resolved the problem, of course. and I thought it was really interesting how it highlighted something about Semaphore that maybe not a lot of people really appreciate. So that's why I'm thrilled that we're able to kind of present a little more expanded. We only had 15 or 20 minutes in the at KM World, so we wanted to talk a little more about it and maybe do an actual demonstration of it as well. So with that, let me turn it over to Jon, and he'll give you a little more background about the challenges that he was that they're doing and some of the issues that they ran into.
Thanks, Jim, and thanks everybody for logging in here. So just a bit about myself and what I do before I kind of launch into things. So I'm Jon Stevens. I work for AbbVie. I work for the information research division of AbbVie. And I work kind of on two teams. I work on the AI team as well as the AbbVie library ontology team. So typically I deal in projects pertaining to scientific literature, how to classify them, group them, and how to get the most relevant literature to our researchers and scientists, given the thousands and thousands of publications that come out every weekday in a given area of biopharma research. So, one thing that we do with the Ontology team, we build these classification engines, primarily using Semaphore, and we around those build, with some help from our development teams, these kind of website portals that you see here for finding literature that pertain to a certain therapeutic area. So this would be an example. You see these drop-down menus here. This would be an example of the filters that would be present for our oncology watch. So for our oncology, one of our oncology research groups, this is like a custom daily updated literature feed where all the documents are tagged for the different cancers that we have some research on, and different genetic targets, and then also various topics, things like diagnosis and cost of illness and stuff like that, as well as with treatments, drugs. And so these things are tagged by Semaphore, and then this allows us to kind of harmonize all the different terms in the abstracts of these articles, and the researchers and scientists can more easily find things that pertain to what they care about. And so one of the nice things about using Semaphore is, we have, of course, our ontologies that we use. In this case would be an ontology. I'm going to say that 5 times fast. But beyond that, we also have some NLP, natural language processing capabilities that kind of make it so that our ontologies don't necessarily have to reflect every possible variant, and we have a little bit more flexibility. So just to give you a really simple example, here on the next slide, we have like the word biomarkers. This is basically the simplest possible example you could find, which is like a plural of a noun in English, where you just add an S. And it seems like a trivial thing, but if you think about it, right? If we pull in concepts from an external source like MESH or some other large biomedical vocabulary, typically all of the variants of the synonyms will be explicitly listed out. So if you have like diagnosis, it'll say like synonym diagnosis, synonym diagnoses, synonym diagnosed, or whatever it is. And but what we do is we often create our own custom concepts, and we pull in from different sources, and we kind of synthesize and we add to these things. And we don't want to have to list out every variant of every word, because it's not very interesting. The fact that biomarker and biomarkers are both, quote unquote synonyms of the same concept, biomarker, is not any kind of interesting fact about the concept of biomarker. It's just like a very simple, boring fact about how English works that applies to almost every noun. And so with Semaphore, if we just put one, ideally, it'll match the other. So if we create a concept for biomarker and we just put a synonym, or let's say we have a concept that's called biomarkers. We don't need to add a synonym for the singular biomarker. Semaphore should stem it down and should match the singular or the plural to that single synonym. So that's one example of the kind of behavior that we want. As Jim kind of alluded to, we had a bit of a wrinkle with how this kind of worked when we updated to the kind of fancier language packs. And one of the things I'll talk about is kind of why that was and what to do about it. But another thing that's nice is beyond just like simple singulars and plurals, you can get into things like part of speech. And Jim will show a cool demo of some things that I probably many of you, I know at first I didn't realize you could actually do in terms of restricting to particular parts of speech. So here's an interesting example. We had for some of our literature watch portals, we have things like body regions that we're interested in tagging for these articles. So we want to know if something is about leg, arm, back, or whatever. And you might have something like back pain as a concept. And I think if you're coming from a traditional kind of librarian sort of searching background, you do something like you could create a rule logic in Semaphore that basically mimics a kind of search where you're like, look for back within so many words of pain, or within the same sentence as a concept pain. If you actually go to try this, you find a surprising number of examples like this one, where you have things like Back to the Future for pain management. Obviously, you don't want that to be tagged as back pain. It has nothing to do with the anatomical back. And this is where actually part of speech can really help, because in this case, the part of speech tagger that comes with the language pack that Semaphore uses, as any good part of speech tagger would, is not going to tag this as a noun. It's going to tag the orange highlighted back as an adverb in this case. And it could also be a verb or other things. But the point is, you could actually encode in your logic, like, we want back to be a noun. And the system actually can look at the context and determine whether that's the case. So kind of putting that all together, we have two, I would say, two main approaches to the issue of, what we computational linguists call lemmatization. So lemmatization is the idea of taking all the different variants of a word and collapsing that under the same lemma, but basically treating it as reflexes of the same linguistic object. And the older way that I think Semaphore used to do it this way, and it's kind of the simpler way, is on the left, which is just kind of a rule-based thing that will do stemming, something like just take an S off in certain cases, chop an S off and try to match that. But the newer way uses statistical models, statistical lemmatization, and can actually look at the context to get more information about what kind of word we're dealing with. So it will stem, maybe, depending on the context, whether it thinks it should stem, will be determined by the context, and we'll also supplement with part of speech information. So on the right, we could take our lexicon, our dictionary of English, the context, the word itself, part of speech tagger, and we can sort of synthesize these statistical models together into a lemma that says, when a patient backs out of a clinical trial, that is a back, and it's a verb, and the stem is back. So these two approaches have pros and cons. Excuse me, I would say the upsides to the statistical lemmatization, the thing that was on the right there, is that it does take context into account, takes part of speech into account, and these models typically involve some level of machine learning, which is great because it can analyze complex rules and patterns in training data. So you're not just hand coding rules, trying to think of every scenario, like you do with like a snowball stemmer or something like that. But the cons are that, statistical methods, machine learning in particular, can be a black box. It's not always exactly clear why the decisions are being made. Like, why was this called a noun and not a verb? Or why was this stemmed and that wasn't stemmed? And sometimes it gets it wrong, and it's not clear why it gets it wrong. And I think it goes back partly to you have to have large amounts of training data for these systems. So you're not telling it when something is a noun or when it should chop off an S or an ED or whatever. You're giving it a whole bunch of examples, and you're having it learn from the examples with hand annotations about what the right answer should be, what those patterns are. And this third point is kind of what I want to highlight here, what we ran into, that the training data is not likely to be representative of every domain. So if you have a general model for English, English part of speech tagging, English stemming, what does it mean English, right? There's not really, I like to say there's no such thing as English. Whether you're talking about dialects, there's, British English, American English, whatever, Indian English, Australian, but also there's genres of text. There's biomedical English, there's manufacturing English, there's AbbVie English, Smartlogic English. So, we have, what we ran into was we had updated to the newer language packs. We had the statistical lemmatizers and part of speech taggers in place, which is a net positive, I think, that we upgrade to this capability, because generally these things do better, generally. But we ran into some examples where things weren't being stemmed that we thought should be being stemmed. So we actually have a list of examples, because we were able to use the reports, the Semaphore reports, and I can't tell you off the top of my head which report this was, but we could probably follow up and show you how we actually did this. But we actually generated a list of things where no stemming was kind of being applied, and then we pulled out the ones where we were like, hey, wait a minute, this should be stemmed and it's not. And we ran into this. We actually discovered it because we had biomarkers, and we had things that had singular biomarker in it and it wasn't being matched, and we said, what's going on here? So then we realized, okay, these are the words in our models for which the new stemmer is not doing what we would expect. And so we wondered, you know, what do these words have in common? I mean, here they're all obviously, well, maybe not obviously. If you don't come from a biomedical background, it might just look like gobbledygook, but these are plural nouns. And then the other thing is, as you know, as a linguist, I immediately picked up on the fact that these are mostly Greek, you know, Greek, morphologically complex Greek words with prefixes and suffixes and things, because you know, Greek was the sort of the fancy language of choice during the Renaissance, when all of the kind of modern medical terminology was starting to be invented. And so you have all of these, you know, echoes and neurals and kinesias and grams and graphies and neos and all that stuff, and bio. And so when you have these sort of morphologically complex, very specific biomedical terms, it's not so surprising, you know, biomarkers and echo encephalographies and things like that. If you're trying to teach a statistical system to recognize patterns from training data, and you know, when it should stem something down, you know, and you're training it on, I don't know, Wikipedia or Google News corpus or something like that, it's probably not seeing a lot of examples of, you know, dyskinesias and geographies. So it can't really learn from what it doesn't see. So this actually made total sense. And one thing you could do is you could say, well, just retrain your model on biomedical data, but we didn't want to throw the baby out with the bathwater. And it turns out, because it was so easy to find out which of these terms were not being handled, you know, there was a really fast workaround that we were able to implement, which is to simply, and Jim will go into a little bit more detail about this, but was to simply tell the language pack, hey, you know, these are plural nouns. Make sure you stem them down. And there are actually ways to do that using the extensibility language pack. It requires a little bit of getting underneath the hood of things, but it's simple enough and it works. And so we were able to solve the problem by just analyzing the places where it kind of wasn't finding what we wanted to. And so there's kind of a larger, I guess, lesson here of when you're dealing with very niche genres, very niche vocabularies of any kind, whether it be biomedical or, you know, automotive manufacturing or whatever, you know, or sales, I don't know. Whatever it is, you know, just be on the lookout for these super specialized vocabularies. And when you go to apply kind of a general English model, you know, do some testing and make sure that there aren't some specialized things that you need to actually add. And so, you know, with that, I can turn it back over to Jim, and he can talk in a little bit more detail, both about kind of how we implemented the workaround for this, and also just more generally, how we're able to utilize the language packs to their fullest extent and do really cool things with, you know, part of speech tagging and all that good stuff.
Okay, great. Yeah, thanks, John. And it was great working with John, because he does have that, you know, computational linguistic background. So I certainly learned a lot working with him as we went through this. So if going back to Semaphore, just to focus on the first two components of Semaphore. If you recall, Semaphore's three primary capabilities: the modeling capability to be able to ingest, manage, share, socialize, distribute, embed the model information into your enterprise. And then I think I like to say that the strongest thing about Semaphore is the fact that it puts these models to work. That you just don't look at them or bring them into your downstream systems. You actually use them to analyze text and generate that metadata that is used to drive the kind of portal experience that John described, or other types of analytics and harmonization that you might need in your business. So we're focused on how these two pieces work together. But I don't want to leave out the last part of Semaphore, which is the ability to take that takes the models and allows you to really easily push them into downstream systems. This can be really useful because you may tag your documents perfectly and extract the correct drug name or or specific disease term in your content. But if a user is not looking for that specific disease, he's using for that class of disease. He's looking for that class of, he or she is looking for that class of diseases, or she's looking for a broader drug class or something like that. You need the model in order to find that information. So to be able to leverage the model in your downstream systems is critical as well. So we're going to stay up here mostly in this section of Semaphore as we talk through this. So this is an overview of the Semaphore pipeline. It's very high level, but I think this, well, like when I said in the beginning, like not everybody really thinks of Semaphore at this level of what it is actually doing, because it's you know, it's, of course I think it's pretty impressive that there's two main pipelines that we're talking about. One is what your content itself goes through. So you're ingesting records from your content management system or from some external source, and you're tagging, and you wouldn't need them to be tagged. Well, the first thing Semaphore does is, in its pipeline, is take that content and then push it through broadly speaking, the NLP stack of Semaphore. And that's where it just takes the content and breaks it apart. It identifies the structure, the zones, like the sentences where words start and end, the paragraphs, etc. It identifies the entity types of people, place, people, places, types of things, geography, currencies, things like that. And we do this in many different languages as well. It's not just English. This engine works with I don't know what the count is right now, 20 to 30 different languages. So we also so in general text mining, we're finding nouns and verbs. We're doing part of speech tagging, noun phrases. You can construct your own type of phrases that you're looking for based on parts of speech. And as Jon was explaining, the part of speech is critical to determining the stemming and lemmatization of words. So all that happens here. And so it gets to the end of this pipeline, you've got a fully interpreted document or piece of text with all that extra information added to it. And in strict text mining exercises, that may be pretty much what you do. And then it's all a big jumble of stuff that you need to analyze downstream and figure out what it means. But the differentiating aspect of Semaphore is that it has this whole modeling component. And so you build your semantic models, or you ingest your semantic models, or I think the perfect situation is in AbbVie's case, where you start with public models because there are so many of them, especially in biomedical research, and you amend them so you identify the diseases that are relevant to you or associated with your therapeutic area or some other business construct in which you're organizing information. And then, in the case of a research organization, you intend to be the expert on these topics. So you'll be adding information that nobody else will know. So that's what you do in the modeling aspect, is you're basically modeling what you know, building on what other people have come up with. And those models get published, and it generates a set of rules. And those rules go through a whole process of identifying the words in the model, and pulling them apart, looking for do you want these words to be found near each other or next to each other or in some proximity to each other? Should it be stemmed, or you're looking for the exact phrase? All those types of processing happens in here. You can have a custom way to handle variants and exceptions. If you find this, don't use this as evidence. If you have a term called President of the United States, and you want to find information that's specifically tagged with President of the United States or some variation of that, you don't want President by itself to also fire for it, or vice versa. Actually, if you're looking for President, any President, you don't want President of the United States to take that word. So that type of preclusion is there's an automatic preclusion engine in Semaphore that you can tailor to what you're looking for. So all that generates a set of rules. And the key is how these two come together. So when these rules get applied to text, it's not looking back here at just the raw text, it's looking at this marked up version with all the part of speech and zones and everything already identified. So it's that where you really get the highest quality metadata you can, because you're really controlling and applying this reasoning to the NLP generated metadata. And that's what you can use to build these really focused portals and quickly get to answers in your analytics challenges more quickly, because you've already identified these the most important pieces. And then you can go down into the details and maybe find more information that maybe you don't already know. And I don't want to leave out this connection between the model itself and the users of the end result of Semaphore. As I said in the beginning, using the model to then navigate the metadata, this tagged information that gets generated by Semaphore is a key aspect of it, as well as the feedback from, as people use the system, what might be missing, what does the Semaphore find in these documents that might be relevant and be fed back into the model for its continuous development. So let's go back to biomarkers and terms like that. John's first example. So there's two ways. The first, our first reaction to when John came up with this challenge, saying, "Hey, I'm not stemming, biomarkers." Well, you could just add the synonym, and like I said, if it's just one word in your entire model, and it's easy enough just to add the variant, just as some public, more generic text mining vocabularies might have. Every possible variant just gets hard-coded into the model, and that's useful. But biomarkers I think is a good example, because biomarkers is often part of some other word. Genetic biomarkers, environmental biomarkers, oncology biomarker. You might have a lot of variants, or more compound phrases that use that term. So you don't want to go and create variants for all of those. The second part of it is these models are coming from some other source in many cases, and they get updated. So every time I update it, I've got to add all these extra variants. It seemed this is a perfect example where we just want to handle biomarkers from the very start, that bottom start part of the pipeline. Let's handle biomarkers at that point. So at the end of that pipeline, the word has already been stemmed correctly, and my rules don't have to do that. And that's what we're doing here in this option B here. So in Semaphore, as John alluded to, it's really a matter of, again, focusing on the bottom part of the pipeline. We're able to analyze, generate a report of all the words in their models and run it against that Semaphore pipeline and say, okay, which ones are we not identifying stems for? And that means that the NLP engine was not trained on the information that had a lot of these types of words, which is understandable. And that's common in NLP engines. So we're able to quickly add these, and it's very, it's not complex to add it. It's not it's like John said, it's a little bit under the hood, but that is a big change with Semaphore in version 4 got something, is that this kind of part of the NLP engine can then be amended like this. And so I think just opens a lot of opportunities to explore for particular challenges like this. So let's look at the other issue. John gave the example of back pain. That was a great back pain. And you think, well, okay, that makes sense. Back is is sometimes ambiguous. Well, it's actually really ambiguous. I mean, back can be used in all kinds of different ways in different contexts. And but what you're really, what you're looking for are the medical uses of the word back. So, and specifically the part of the anatomy known as the back, or perhaps a symptom of back pain. But you don't want baby back ribs, and even other clinical terms, like the patient backs out of a clinical trial, or the back of my leg. I don't want the back of my leg. I want the back as the anatomy. So if you look at the part of, so you think, well, maybe part of speech can handle it. It's like, well, the back is a noun, right? But well, so is I've got your back. So is the back of my leg, etc. So actually, part of speech helps, but it doesn't get you all the way. When these are the actual ones you're looking for, and some of them are actually adjectives when you're looking for back pain, etc. There's some other examples I'll show you. So let's look at this another way. I just kind of like to illustrate it like this. So you've got a concept, a medical concept. It's very specific in terms of what you need. Back as an anatomical site. Some vocabularies even word it this way. This might be this SNOMED term or something. So, and on the right-hand side is the text that you might be dealing with. Some of them, and you might say, well, I'm never going to see the word, actually, these are all medical type terms. So I was thinking some of the, baby back ribs, you may not run into that type of text. But these you might, and you're not looking for, you're only looking for the ones in blue. So the first thing you could do is add a part of speech tag. And this is what you can do in Semaphore, because remember the pipeline, what the Semaphore rules get is a marked up set of text that has the part of speech and stems already identified. So you can say, okay, well, I want the back, but only as a noun. And that works partially. It finds these examples. My back hurts, I have a rash on my back. The family's backs were all sore. But you know what? It also finds the back of my legs, back of my neck, and it also does not find this. And I really like this example because why doesn't it find this? Well, it went through the natural language processing, right? So we've got this marked up thing. We know the part of speech. Well, I think this is really interesting because this is not natural language. I mean, it might be in a form. A form is not natural language, and how much of your unstructured data that's the challenge is actually forms. They're not written in sentences. And then think about terminology like things that are in tweets or hashtags. What are those? They're not what we consider natural language. So how do you address challenges like that? So the first thing you could do is, well, actually, using that preclusion capability that I alluded to and probably didn't explain very well. I'll try to explain it better this time. That here I'm looking for back, but I want one way you can preclude it is saying, I want back, but I don't want a back as a noun followed by another noun or a preposition, back of, back to, well, it doesn't find these because they're not nouns, but there's other examples where these other parts of speech shouldn't be following the noun. So that'll take care of these. So the preclusion rule will take these out of what it finds. And so that's good, that solves that problem. And in typical preclusion, you might, and the first thing I actually did when I was trying to working on this was to say, oh, well, I'll just add back of my legs as a precluded term. So find the nouns, but don't find back of my legs. And I talked to other information scientists here, and they said, well, actually, just keep using the part of speech. And you start chaining them together to look for exactly what you expect. So, but we're still missing this non-natural expression here. Because it really doesn't know what this part of speech is. I think by default it makes it an adverb because it doesn't know, it has no other context. So what we'll do is add, then we just go back to a modeling. It's not natural language. So this is where modeling makes perfect sense. So all we need to do is enter the evidence that will find this terms expressed like this. Body back isn't really a word, but it would isn't really a phrase, natural phrase, but it does show up in this type of example. And analyzing forms, finding anchors in forms, and then extracting the data next to it. That's a big thing of that Semaphore gets involved in these days. So there's a whole other webinar to get into that topic. So let's go to all this is all abstract here, but you can actually do this in Semaphore. And so here's an example of the concept of back in Semaphore, and we've added some additional evidence for this anatomical site concept. And the part of speech tags can be added directly into your labels. I'll add one caveat to that, because for those people that understand that part of Semaphore, Semaphore automatically looks at these brackets and deals with them. You have to make sure Semaphore is not doing that. And then these part of speech tags will be passed directly to the rules. So I'm going to show you this in action. And the exciting part of this is I'm actually going to use Semaphore version 5, which is about to be released. So I'm going to bring this up on my screen. This, ladies and gentlemen, this is Semaphore version 5. And we call this a view of Semaphore the Semaphore Studio because it pulls in all the different components of Semaphore. Those three pieces, the modeling, the classification, and the integration. Well, here they are brought together, and so it makes it much easier to work with Semaphore. And there's additional capabilities of you can manage your license in here, so you can actually see exactly what you license and information about that. Whereas before you kind of have to go to this customer portal to look that stuff up. And so we have our three components. We're going to go into the modeling component because that has some new features to it as well. When we first open the what we're calling the knowledge model management part of Semaphore, you will see the models organized in a different way. So you can actually add some organization constructs to your models. So I have something automatically selected here. If I turn that off, you can see I can add categories to my models now. So I might have many different models. AbbVie, I know, has many models, and so I think this is a big help for people that work in that type of environment. So I've tagged some of these models. That's why I can narrow down on just the ones I've tagged with Biomedical, or maybe I want the ones that are the Smartlogic models that come with the product, or maybe I want the ones that deal specifically with fact extraction. And these colors as well is something you can add. So you can also use color as kind of another dimension to how you manage your models. So I think this is a really nice feature. The other part of helping you manage your models is it brings up your most recently accessed models to the top here, as well as the tasks if you're using tasks to control the workflow of how your models are updated. So of course I have my text analytics demo right here up here in my recent models tagged with Biomedical. So I'm going to open that up. And here we have Semaphore. Let me blow it up a little bit. And this is a a model, created for this demonstration. So it's not a complete model of terminology, but you can see we have our anatomical sites. I'm going to pick the back, and we'll see I've got those evidence labels added here. So let's go to the other part of Semaphore. Let's go back to the top. Let's go back this way. And now let's go to the classify option. This is going to a new tool that'll be available to you, is what we're calling the document analyzer. And this works a lot like our other analysis tools, but it adds some specific features that deal with this part of Semaphore, the part of speech and the stemming and fact extraction. It's focused on making the analysis of that that capability of Semaphore easier. So I have a test document here that has some of that sample text we were looking at. And if I send this for classification, we'll get our sample text echoed back on the right. And here's some of the additional features that you get in the document analyzer. You'll see here we have a special tab for semantic analysis. And that's where we can actually look at the part of speech and stemming. So this is really cool. You click this, and voila is every part of speech that it was able to determine in this text. So it's really useful to say, well, why didn't in my corpus of data that I was processing, I wasn't finding this content? Well, let's take one of those documents and throw it through here and see, it's because it's interpreting this as a noun when the way I use this word is as a verb. And you can see that, and then adjust things accordingly. The other thing you can see is the stems. So that's kind of cool. So there's some simple stems like backs turning to back, families is separated out as family. Where are some other ones? Backs. But you'll see all those variations here. So that's also very useful. You can turn the both on. So it's a nice feature. So it's, but we can also look at our rules themselves. So I have a couple rules that are active here. And if we click on the body part, we'll see exactly the evidence that it found for this. So here it's not finding Back to the Future. It's not finding patient backs out of a trial, backs on my legs. All these are being precluded by those adding those phrases to the rules. And I have symptom active as well here. Back hurts, back sore, back pain. So that is a demonstration of Semaphore 5 applying the use cases we were just talking about. I'll go back to the presentation here. And I guess in conclusion, I hope in this presentation we've shown how the combination of the NLP engine plus modeling aspects gives you this level of power and flexibility to find exactly what you're needing and create high quality metadata accurately and and traceably. So I could go back and say, well, why is this happening? What can I do to find exactly what I'm looking for? And in specialized domains, this can be particularly useful because for those phrases and words that you're looking for that are really important to you, but maybe not important to other companies, and that's why you're competitive, you can tailor the system to be very specific to what you're looking for, and handle the large volumes of text in a consistent way. And I think one of the big differences between the previous NLP engine, which did have some statistical capabilities in it, as well as some more basic stemmers, But the newer engine has this kind of openness to it where you can provide some flexibility to it, like we did with the biomarkers example. And this will continue to develop. I think as John's example showed, and many other examples that are coming up. This is a real kind of a special new area that Semaphore is kind of uniquely able to address. And I hope that is compelling to you. I certainly thought it was, and I learned a lot in this process. And any other thoughts, Jon, you wanted to add?
I'll just add one thing, which is that, when we were doing this, we did not have 745 because it wasn't out yet. And I was happy to see the document analyzer because, we were kind of reluctant to put some of these solutions into production just yet because we were like, well, we don't quite know what the part of speech tagger is going to do, and you can test it out in Semaphore 4, but it's a little bit more roundabout and not as easy to do. And so this way, I was thinking, it'd be great if we just could put a bunch of examples in and just see exactly what the parts of speech are for all those examples, in like one click. And so anyway, that's exactly what we have. So it was actually pretty cool to see that, given all the stuff that we had worked on.
Yeah, cool. Okay, thanks. So I'll turn it back to you, Anne, for any questions that have come up.
Okay, thank you. Thanks, Jon and Jim, for a great webinar. A couple things I'll just go over again. Yes, we are recording this webinar, and anyone who's registered for the webinar will receive the playback information tomorrow. So with that, we do have a couple questions here. I'm gonna let's start. Okay, so here's one. So noticing that both Jim and Jon worked on this together, one of the questions is this type of modeling and classification something a taxonomist could do on their own, or does it really require additional training from Smartlogic or professional services assistants?
Yeah, that's a good question. Yeah, go ahead, Jon.
Yeah, well, just my perspective is, I think these things are implementable. I don't think it's, you can't just intuit like right off the bat kind of how you implement these solutions, but I think it's something that you can easily be trained to do. It's not super complicated. It helps if you kind of know a little bit about linguistics and what nouns and verbs and stuff are, but I think the solutions are pretty straightforward. You need a little bit of training, I think, to kind of get at them. I don't know if you agree, Jim.
Yeah, some basics, but I will emphasize, the design principle of Semaphore is to put as much capability into the model as possible. So that's why I wanted to highlight, just adding the part of speech tags to the model directly and having them being picked up by the engine successfully. But knowing more about how to do that, the Semaphore training classes are useful because the advanced classes especially kind of get under the hood and look a little more detail about what Semaphore does. Yeah, I think in most cases the way things work is you may use some professional services if you have these particular types of challenges. Professional services can help get you started and help getting things set up. And of course, all our professional service staff does that in a way that when they're done, you're managing things in your model. You're not tweaking some other under the hood aspect of Semaphore. So if we're doing everything right, that is the end result. You should be managing how Semaphore works in your model in collaboration with your subject matter experts. But like I said earlier, I learned a lot about linguistics and how these NLP engines work just from collaborating with Jon and the other systems developers and information scientists here. So it's definitely worth exploring.
Okay, thank you. And another question. This was really a good example of in the biomedical space. And do you see that this process be extended to other use cases, other industries?
Yeah, I mean, my thought is, I gave kind of a little abbreviated version of this to a client, just a short introduction to the part of speech side of things. And I said, no, I don't know if this is relevant to you. I mean, and this was in transportation company organization, and they were like, oh yeah, like a lot of the words we use are very specific. They're a public transit system, so they have like a lot of boards, and even though and we just like board, like the word board is and board agendas. So they were saying, oh yeah, I think this is entirely appropriate. We want to consider how this might help us. So, and that's just anecdotal. I'm sure if you start thinking about other industries, it's very much the case. Especially in one of our clients is a engineering manufacturing company, and a lot of them deal with like little records of repair. So they're like written in this abbreviated word language of mechanics, and there's millions of these little records that they process, and yeah, they also leverage the language packs in special ways in order to interpret that kind of specialized language correctly, as well as the other parts of Semaphore. I don't want to downplay that. I mean, the modeling, you can do a lot with modeling, and there's variant handlers within the modeling part of Semaphore and how the rules are generated. And so again, professional services or using support to find out which is the best approach for what type of problem that makes the most efficient use of Semaphore.
Okay, I have another question here. Can you clarify the foreign language part of speed tagging? Is it fully supported?
Yes. And if anybody else from Semaphore, I should have been prepared for this answer. The number of languages is somewhere between 20 and 30, I forget. But it's and with Semaphore 5, it's another updated version of the language packs. So there's actually more supported. So that's another big plus with the Semaphore 5. Additional entities, new training sets that they used. So it should be even better. But anyway, so it's and across those languages, there are different degrees in terms of how many entities can they find and things like that. So certainly in the most common 10 to 15 languages, it's as rich as it is with English.
Great. Okay, I have a couple more questions. John, what is next on the horizon? So do you see additional things that can be done on your current project, and as well as are there opportunities for other areas in the company to use the same kind of process?
Yeah, I think that having done this, I mean, I think we kind of got to a good point on our current, or the projects that were current last year when we were doing this. We kind of got to a point where we were satisfied with the classification and the tagging. I think we could go further in the future with refining other concepts using things like part of speech information. And as I kind of mentioned, I had been kind of reluctant at first to kind of go crazy with it without really being able to test out what the part of speech tagger is going to produce, and being able to easily like sanity check a lot of the behaviors of these kinds of rules and labels. And so I do think that will be easier once we get everything upgraded to 7.4.5. Like to the extent that we can do that testing, I think we could go a lot further with it in terms of I think there's a lot of ambiguity that you can reduce even just with part of speech. I mean, that's not everything, but it can help. But a combination of that, and as Jim showed, like preclusions. I mean, and we do a lot of that. We do a lot of kind of like, don't match this, and we use different label types for that. And I think going further with that, because we do have a lot of cases where things are kind of ambiguous, and you don't want to, again, you don't want to sort of throw the baby out with the bathwater and just get rid of every ambiguous term. You want to be able to refine. So I think we could definitely go further. We have a lot more of these projects in the pipeline. So some of them are just getting started. So we'll see kind of how far we can go with that.
Sounds great. I think it looks like we have time for one more question. And it looks like it goes to Jim. Jim, can Semaphore 4 extract data or content from tables for accurate fact extraction with a high confidence score?
Yeah. I think it's kind of ironic that when we create documents, we create tables in documents so that they're easier to read. So a human can look at a table and look at data in that table and understand it very easily, whereas a machine seems to have trouble with the table because it needs to pull apart the text, and tables can be a challenge in doing that. So in Semaphore version 4, the later versions of 4.3 perhaps, we've extended the capabilities of Semaphore to handle tables much more effectively. In fact, a project at AbbVie, in fact, in a separate group, was working with extracting information from tables specifically, and we used this new capability to plug in a different type of interpreter of tables and text in general, but it was specifically the table handling that we were focused on, and it made the project very successful in the end. To employ that capability. Yeah, we're definitely, that is a big recognition on Semaphore's side on our product development, how important that is, and we've taken the steps to address it. Are you still there, Anne?
Oh, I'm sorry. Yes, I am. Sorry, never mind. Anyway, thank you everyone for joining us, and thank you Jim and John for your expertise and your time. We appreciate everyone's connecting with us, and we hope you'll come back for our next webinar. Everyone have a great day.
Thank you so much.